So we were at, down to misuses of statistics. Yes, right there. We did the levels of measurement. Now we're going to talk about, you know, there are some devious people in the world. Just a few. In fact, it was Mark Twain that said there's liars, damned liars, and then there's statisticians. And people that practice statistics, if they're unethical, use statistics to support lies, so be careful. Okay? For example, this is as at the bottom of the page that has the summary of types of data at the top of it where we left off last time. Two kinds of misuses of statistics. First one is, here's where you are. Okay, bottom of the page. There's a picture of that first graph at the bottom corner of the page. The first kind of misuse of statistics is evil intent on the part of devious, dishonest people, which, by the way, does not describe all statisticians. So the first misuse is evil intent on the part of devious, dishonest people. But a second misuse is unintentional errors on the part of people who simply don't know any better. They don't think things through. For example, on this first graph, notice that it is exactly the same graph. They're comparing average salaries or average personal per capita income in the states of California and Nevada. But this graph looks far, far different from this graph. And that's because the graph on the right does not start at 0. What someone did, either intentionally or unintentionally, was they took this graph and they only showed you this much of it. So if all you see is this much of it, which is this graph, what does it make you tend to believe about average per capita income in Nevada compared to California? A lot less. Those people, you know, unless you actually look at those numbers carefully, you're probably thinking, you know, those people are probably all on welfare. They can't possibly be making any money. They're all poor because that bar is so short. And the human brain doesn't necessarily look at this number in comparison to this number. We simply look at the picture. And the picture this way, presented this way, tells a far different story from the picture presented as it should have been with a starting point of 0. Because you can see in this graph on the left that, yes, there is a difference in the per capita income in Nevada and California, but it's only a couple $1,000s. It's not really that much. Not as much as this makes it look like it is. Okay? So they're conveying the exact same information. It's just this one is misleading. That isn't to say the person that constructed graph B was trying to be dishonest. They may just simply not have known any better and thought, well, you know, this is where most of the difference is. Let's just show them the part where the difference is. But they're not telling the whole truth at that point. And this is even worse. Always be careful when you see anything on the internet or a magazine or in the news or on television or anywhere that shows you a picture of two things as comparison. Because if you're looking at a picture of oil barrels to compare the USA and Japan, because this actually looks much, 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 much bigger than this. This looks like comparing a 5-gallon bucket to a soda can. It really does. But if you look at it more realistically with a bar graph at a starting point of 0, you see that, yes, the U.S. does basically use lots more oil than Japan, but this looks like they probably use, I'd say, 20 times more, 15 times more, whereas this shows you they probably use about 4 times more. So be careful looking at three-dimensional pictures that represent data, because that's very, very misleading. You always want bar graphs or pie charts, flat two-dimensional graphs, because our eyes can more honestly judge the differences in those things. Another thing to be careful of, and this goes on to the next page, another thing that you need to be careful of is small samples. This comes under the category of bad samples. Conclusions shouldn't be based on samples that are too small, far too small. For example, if I decide to base a school suspension rate because I'm the head of the Board of Education, and I look at 3 students and decide that because these 3 students did this, this, and this, then we're going to have a school suspension rate that is terrible because 2 of those 3 students got suspended. 67% of my students are getting suspended from school. Well, no, you only looked at 3 students. There's like 1,300 students in your school system. You just picked the wrong 3 students. You needed to pick a bigger sample. So that would be a bad decision, being based on a sample that's too small. If I looked at a group of 5 people that took an exam and thought, oh my gosh, I did a horrible job on teaching that exam because all these people failed. Well, I probably have at least 50 people taking my exams. I certainly shouldn't base everybody's, whether I did a good job for most people on only 5 of those people. I need to look at it, at least 15 or 20 of them to get a better idea, and I need to make sure that it's a random sample. Be cautious, and this skips around a little bit, so the notes are not in exactly the same order. Be cautious about missing data. That's about 2/3 of the way down the page. Missing data can dramatically affect results. Subjects can drop out for reasons that have nothing to do with the study. The U.S. Census suffers especially from that because if you think about it, the U.S. Census claims to count every single person living in the United States, every single U.S. citizen. But that's hard to do. We have soldiers that are overseas. We have people that are on vacation when the census gets counted. We have people that are working overseas even though they are U.S. citizens and do have a home here in this country. We have people that live in their cars and under bridges, more than a lot of people realize. We have people that simply aren't going to answer the census because they don't want to. So it's really hard to actually collect real census data. Not everybody is going to want to provide information. And those people, a lot of times, really, by not providing the data, they have a huge impact on the results of the study because they had something important to say. Everybody has something important to say. So everybody should be allowed to be included in your sample, or in particular, if you're trying to take a census, everybody needs to answer. Because the census is the population, not a sample. Excuse me. Be very careful of what's called a self-interest study. Some parties with interest to promote, some special interest to promote, they're going to sponsor a study. For example, one of the biggest deals I can think of in the last 50 years was that there was information being cited by the medical community that there was a huge link between smoking cigarettes and heart disease and lung disease and all kinds of other illnesses, but the tobacco companies were doing studies and finding that there was no connection whatsoever. Well, that would be because the tobacco company wanted to make sure that that was what the statistics said. So they would carefully choose the data that they presented, and if it said something that went counter to what they wanted you to hear, you never heard about it. And it wasn't until the 90s that all the hidden, covered-up stuff where they've been adding chemicals to tobacco that caused people to have cancer. It's not really the nicotine in tobacco, it's the added nicotine in tobacco that causes people to get addicted. It's because of all the added preservatives and chemicals they put in tobacco to make cigarettes that caused people to get these illnesses. And that was all hidden from the public until the 90s. So that's a good example of people with special interests. You know, you don't really want to have them telling you what's going on. You want an unbiased source. Be wary of a survey in which the sponsor could enjoy monetary gain from the results, like, for example, a tobacco company. Or, honestly, if you watch television, drug companies market to people these days. Ask your doctor about XYZ. You might need that. Well, you might not have ever thought about needing that if they hadn't pointed it out to you. Maybe you don't need it at all. But they paid for the commercial and they paid for the study that said it might be good for you. So be wary of things like that. That's one of the reasons you're taking this class, is to learn that, yes, there's a legitimate use of statistics, but there are people that are going to be out there trying to fool you with those same sets of data and same statistics. So we want you to be educated consumers. When assessing the validity of a study, you should always consider whether the sponsor might influence the results. That's the bottom line. Does the sponsor of the study have a vested interest in the way the study comes out? Are they likely to make more money by making the claim they're making based on statistics? Be careful also about a voluntary response survey, a sample in which the respondents decide whether they want to participate. Typically, the only people that participate in a survey are those that have a strong interest in the topic, either for or against, which means that you're getting extreme results and you're not hearing from everybody's opinion. So remember, your sample should include as many people as possible, those that have strong negative feelings, strong positive feelings, and ambivalent feelings should all be allowed to have a say. One of the biggest potential problems is the basis of collecting the data. Statistical methods are driven by the data that we collect. If you don't have good data, you don't get good results. You can't draw good conclusions. There's two ways that we can actually get data from two different sources. The first of these is observational studies. And the very term tells you kind of what it is. You observe something, you look at something, you watch something, and you record information from it. And then on the other hand, there's something called experimental studies, or experiments, where basically, rather than just observe the subjects, you actually do something to them to see how it changes them. So in an observational study, that's when you are observing and measuring specific characteristics without attempting to modify the subjects being studied. The data collection lab that we're going to do is going to be an observational study. When you open the data collection study, it's going to say, what is your gender? It's going to ask you how many credit hours you're taking. It's going to ask you, what is your arm span in inches, so you don't need to get a tape measure and hold your arms out and have somebody measure fingertip to fingertip. It's going to ask you how long your right foot is without your shoes and socks. So you're going to have to get a tape measure and measure from the back of your heel to the end of your toe. It's going to ask you, how old were you on your last birthday, how much change, as in coins, not paper money, how much change do you have at the moment that you collect that data. There's some other questions in there. You're going to collect that data and turn it in for a homework assignment. Normally I do that lab in class, but because of the snow and everything else, I'm going to have to assign that to you as a homework. And I'll be sending you out a reminder at the end of class of everything that we have due next week so that you don't miss something or overlook something, and you don't think, oh my gosh, I've got to get this done, and then find out it's not due for 2 weeks yet. Okay? So observational study, that's where you just observe the subject and collect information. You make no changes. You don't attempt to influence them in any way. As opposed to an experiment where you apply some kind of treatment and then observe its effects on the subjects. Drug studies are often this type of study. So looking at these two examples, the study, determine whether this study is an observation or is it an experiment. How do you know it's an experiment? Okay, that's very good. The first one is an experiment because they didn't just look at people having heart attacks. They took 300 people and 125 of them, they put them on an aspirin regimen. They had them take basically the equivalent of a baby aspirin every day, an 81 milligram aspirin. And then 175 of the people were given a little sugar pill that looked just like the aspirin. So probably neither group knew whether they were really getting the aspirin or not. Probably the people conducting the study, if it were double-blind, the subjects didn't know whether they were getting the real pill or if they were getting a sugar pill, and neither did the people collecting the information from them. They had no idea which group the subjects belonged to. That's called a double-blind study. What about the study of how elementary students color in their coloring books? That's just observation. You're just watching the kids color. So you're not imposing any kind of treatment on them. You're not saying, you know, well, here, let me give you a different picture. You color this picture and you color this one, and I'm going to see which one of you colors better. You're not doing anything. You're just simply observing. Now, let me back up and make sure I haven't missed anything. Let's back up to the previous page just 1 second. Right underneath bad samples and before small samples, it says something about correlation and causality, and I don't have a slide for that, I don't think. Let me flip ahead for a second. Convenience. I'm looking for the... Yeah, voluntary response samples are also called convenience samples. At the very top of the page, it's also called a convenience sample. Although there are convenience samples that are not voluntary response, there are samples like, I'd like to know what everybody's going to do this weekend that's a student at Northeast State. But I don't really feel like going to all the campuses and emailing everybody and collecting that all. So I'm just going to ask you guys, what are you going to do this weekend? Can I infer what everybody that's a college student is going to do this weekend just by asking y'all? No, because y'all are in the same class and probably influenced by the same homework assignments, the same kind of schedule. So, you know, you're not necessarily like the people in Johnson City that are on a block schedule, or the people who are taking classes at night because they work during the daytime, or things like that. So voluntary response is one kind of convenience sample, but another kind of convenience sample is one where the person that's conducting the study basically is too lazy to do it right. Okay? Correlation and causation. Let me flip ahead a few slides and make sure I don't just have it out of order, because I think I might just have it out of order. No, I forgot to put that slide in there, so let me explain what the difference is there. Concluding that one variable causes the other variable when in fact the variables are simply linked. Two variables may seem to be linked, for example, smoking and pulse rate. The relation is called correlation because they do seem to be, higher pulses maybe corresponds to how many cigarettes somebody smokes. That doesn't mean smoking more cigarettes necessarily causes the higher pulse rates. You need to control for other variables. Yeah, that's another good one. Yeah, when people eat more ice cream, there's more gun deaths. Well, okay, yeah, but there's something that causes both of those things to happen. When people get hot, they tend to get mad, and if they have a gun, they tend to shoot somebody. When people get hot, they want to cool off, so they eat ice cream. So even though there's more of both of those things in the summertime when it's hot, that doesn't mean that eating ice cream made somebody go out and kill a bunch of people. Okay, so, it makes real good sense sometimes why something isn't causality. A couple of other things that you might think about is how old a person is and what their salary is in the same kind of job. Is it necessarily just because someone is older that they're going to get a higher salary? Does getting older mean you're going to make more money? Does that seem logical? I mean, there is a relationship. Older people do tend to make more money than younger people on the average. But is it because they got older? No, because job experience, opportunities for promotion from having been there longer, which kind of relates to age, but not necessarily because... Yeah, you learn how to do your job better, so you learn more. So that ties in with experience. You might get promotion, which ties in with experience. You might get more education. You might say, hey, I really don't like working this front-end counter. I'd really like to have the job like my manager's got, so I'm going to go back to school and get an education and get more education, and then I'm going to make more money. But just having more candles on your birthday doesn't equate to more dollars on your paycheck. So there's another one where, yes, those things do tend to both rise, but one doesn't necessarily cause the other. Okay? So correlation means a relationship between two things. Causation doesn't mean one caused the other just because they're correlated. And that's what that note says in the middle of that page above small samples. So let's talk about types of samples, and then we're going to do an activity. Two things may be correlated, but one cannot conclude that one causes the other. Okay, middle of the next page. Types of samples. There are 3 different sampling techniques. We are going to go over these. We are going to review these. And then we're going to do an activity also to help you understand these, because you cannot just memorize these definitions and they make any sense to you, and I know that. This is on the middle of the next page after the one you were just on. Right in the middle of the page it says random sample. Right above that it says other types of data collection methods. Census, that's when you get data from the whole population. Sample is when you collect data from a part of the population. Let me show you where I am so everybody's in the same place. Census is the data comes from the whole population, every member. Sample means the data came from part of the population, but not all of it. And when we try to survey, that's what we're getting is sample data. That's the difference between a census and a survey, is the source of the data. Census is the population. Survey actually comes from a sample. A simulation is where you don't have the population. You do work with a sample, but what you do is you figure out some way to use a computer or some other kind of method to simulate something to see what happens. And the best explanation I can give you for a simulation, I might want to have you roll some dice to determine which numbers or which sums come up more often. Roll a pair of dice to see what numbers, what values come up the most often. It could be anything from 2 to 12, 2 1s or 2 6s, and then there's all these numbers in between. And I want to roll the dice 1,000 times. Well, let's face it, you and I are going to get really tired of going 1, 2, 3. But I can get the calculator or a computer to simulate rolling those die by rolling one die, choosing randomly numbers from 1 to 6, and on the other one choosing a second number from 1 to 6, having it add those two numbers together and then repeat that 1,000 times. And a computer or a calculator can do that in seconds, whereas it'd take me all day. So that would be a simulation. Yeah, it could be a computer-generated data. Another good example would be, let's suppose that I am a naturalist, a forest worker, and I'm trying to study the effect of wildfire on the reproduction or the reclaiming of the wildlife population after there's been a wildfire in the forest. Well, one thing I'm not going to do is I'm not going to go set a fire and watch and see how long it takes all the trees to go back and all the rabbits to come back and all the deer to come back and all that stuff, because for one thing I get arrested and put in jail. But I still need to study what happens with that. So one of the things that I could do is wait for those things to happen, but that might take a long time. So I could enter the conditions for such things from known times that it has happened into a computer and write a program and have the computer model what happens during a wildfire without actually having anything burned down. The NASA uses that quite a bit when they try to do space flights. They, if they're trying to simulate what if we have a space shuttle take off under these conditions, they don't want to have the space shuttle do that because people get killed, but they can have a computer simulate what's going to happen to the space shuttle when the temperature goes really cold or when the winds are really high. That's exactly right. They use computer models. Exactly. 90 times when the weather conditions are like this, 90% of the time it did this. So that's what we're going to say is going to happen this time. That's really what it says. The other thing is when they tell you there's a 90% chance of rain over this area, don't take it that there's 9 out of 10 chances it's going to rain and you're looking out the window and there it's pouring down. So you're like, no, that's 100%. Really what they mean when they say that, sometimes people misuse statistics there again because they don't know any better. And they'll say there's a 90% chance of rain tomorrow. What that actually means is that 90% of the area is likely to get rain, and 10% of the area that they're looking at is not, based on climate conditions that are identical to what's going on right now. That's really what they're saying. So be careful of people that misinterpret themselves, even though they might have really good numbers, their data might be accurate, they're misinterpreting what it means. So simulations are used a lot in data collection. Surveys are used a lot. Censuses, there's only one place that does censuses or claims to, and that's the Census Bureau, and that's every 10 years. Other than that, it's really kind of hard to get census data. So moving on to sampling methods. We're going to go back to the PowerPoint here. But that's not the right PowerPoint. Let me get back to the other one. We're going to focus on these kinds of samples. Random, systematic, stratified, and cluster. Random sampling always, 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 always requires technology. They never actually had random sampling before they had technology. You have to either have a computer or a calculator, which is basically a mini computer. The things that your cell phone can do today, 100 years ago, it took a computer that was bigger than both these rooms to do a third of what your cell phone can do. So actually, random samples have only been able to be collected for about the last, easily collected for probably about the last 60 years. Basically, the definition of a random sample, and there's actually two parts to this. This is the first part. Random sampling is selection so that each individual member in the population has an equal chance of being selected to be in the sample. Everybody's chances are the same. That's part one. Part two is that every sample of a particular size has the same probability of being selected as every other sample of that size. Every sample of a particular size has the same chance of being selected from the population as every other sample of that same size. Yes. In units. Okay, let me back up. In answer to this, the simple random sample of n members, or n units, n individuals, selected in such a way that every possible sample of the same size n has the same chance of being chosen. Let's suppose n is 10. Okay, let's suppose I were going to choose 10 people from all of my classes. If it's going to be a simple random sample, I would have to number everybody in my class to figure out how many students I have. And then I would have to sample it so that a sample of 10 students of a certain given set of students has the same chance as another 10 students of being the one that I select. And that sounds more, it's easier to see happen than it is to actually explain how it happens. That's why we're going to do the activity we're going to do, so you'll understand it better. Systematic sampling is that you randomly select some starting point, and that word random is important. It's not even put in the definition, but the starting point must be randomly selected. So you select some random starting point, and then select every, it says kth, but k represents a number, so every 4th, every 5th, every 20th, every 50th, or every 100th member of the population, depending on how big your population is. For example, if I wanted to get a systematic sample of the students enrolled at Northeast State just on the Blountville campus, let's tie this down a little bit so that I don't have to go all over the country. If I wanted just a random sample of students from the Blountville campus that are enrolled this semester, I could ask them to generate me a list of student ID numbers that are enrolled just on this campus. And then I would count how many of those ID numbers there are and number them. And let's say there's 2,500. I think there's probably more than that, but let's just randomly say there's 2,500. And then I might decide to take every 25th student out of that 2,500. what I would do first is I would randomly select one of the first 25 people. I randomly select using a random number generator to choose a number between 1 and 25. And I would start with that person. And then I would count to 25, and the next person that I got to, the 25th person after that starting point, would be the next person in my sample. And then I would count 25 more students down the list, and then that student would be in my sample. And I would keep doing that until I got through the whole entire list. That's a systematic sample. Okay? Now, I have another explanation that will kind of show you a little bit in a more illustration way, but this is just for filling in the notes. Because I know this is the hardest thing for people to do. So we're going to spend some time on this. Convenient sampling. You use the results that are easy to get. She hangs out her window and yells at the guy walking his dog, "Hey, do you believe in the death penalty?" 3 things are going to happen. One of 3 things. She's going to yell, "Hey, do you believe in the death penalty?" And because he feels really, really strongly about it, and he has these very fundamentalist views that say, no, it's wrong, it's wrong, it's wrong, it's wrong, it's wrong, he's going to turn around and he's going to scream, "Of course I believe in the death penalty. You know, if people do something terrible, you should kill them." Or he might be at the other extreme of that. He might fundamentally believe that you shouldn't kill anybody. So then he's going to turn around to her and he'd say, "No, I don't believe in the death penalty. What kind of horrible person are you that would even ask me that? People shouldn't kill other people." Or he might be somewhere in between. And if he is somewhere in between, there's a really good chance that he's going to keep right on walking and not say anything. Because he doesn't want the confrontation. So yeah, it was convenient for her to ask him, but do you think she learned anything useful? Probably not. Then we have something called stratified sampling. That's where you subdivide your population into at least 2 different subgroups that share some characteristics, like all the women and all the men, or all the freshmen and all the sophomores, or all the people that drive trucks and all the people that drive cars. You know, you can divide them under all kinds of circumstances. And then you select some from each group. The key here is that stratified sampling is you take some from each group, some from all groups. And that makes it different from cluster sampling, because cluster sampling is you subdivide the population into sections or groups or clusters, and then you randomly select some of the groups and take all the members from some. All from some is cluster, some from all is stratified. That's basically, all from some is cluster. Cluster equals all from some. Stratified equals some from all. So we have some examples here, and I want to make sure these do. We're going to go over the ones here first, and then we'll go over the ones on your handout. Let's just, everybody answer out loud, and then I'm going to ask you to do the ones on your handout. What sampling technique do you think I'm using? Using a random digital dialing device. Researchers call 3,258 Kingsport residents and ask what grocery store chain that the person that answers prefers. Yeah, that is actually random. You can't, because what if somebody's not home? What if the 3-year-old answers? What if grandma's home and she doesn't do the shopping? You know, so it doesn't guarantee, the sampling technique doesn't guarantee good data. We're just going to identify the sampling technique. I'm not saying that any of these are good or bad. It's just a way somebody gathered a sample. Corn is planted in a 12-acre field. The field is divided into half-acre subplots. A sample of corn is taken from each subplot to determine the estimated harvest. Stratified because you're taking some from every subplot, so some of all. Yes. The key here is that there's a sample is taken from each subplot. You're taking a few from every subgroup. So that is stratified. Number 3 says, questioning people as they left the local warehouse store, a researcher asked 523 people about their exercise habits. That's a convenient sample. That's what I like to call a Walmart sample, where you just go stand at Walmart on Saturday morning and ask somebody something. You know, what if they went to Kmart that day? Or the other Walmart? Number 4, a newer subdivision is divided into 12 sections based on location. 4 of the sections are selected to determine opinions about the new homeowners association fees. So they've got 12 groups, but they only pick 4 of the groups and ask everybody in those groups. Cluster sample, very good. A line manager at the local manufacturing plant checks every 115th bat bearing or ball bearing for the correct weight. Systematic. He counts them and picks up every 115th one. Okay. Let's double check and make sure that you're good on this. That's my review slide, so we want to look at this. So here's what I want to do. I'm going to leave you right here with this for a minute. You have 5 different samples given there. I want you to collaborate with your neighbor, and at the same time, I also want you to take a short break. You're going to reconvene at about 10 p.m. I want you to answer those 5 questions, and then if you need to go to the bathroom, go. If you need to go get a drink or whatever you need to do, go ahead and do that, and then we'll finish class up with an activity. But I will answer these when we come back to make sure that we all agree. Versus small and very size population. Like Great Basin, school suspension rate on 3 students over the whole. Okay, let me flip through the pages of the notes. Under types of studies, you may have something. Actually, if you'll watch the My Stat Lab videos, you can fill this out, but I will tell you the answers. Okay, it's the very last page of the notes. Types of studies. Types of studies. Cross-sectional study. The data are observed, measured, and collected at a single point in time. Doesn't necessarily mean in the space of an hour, but it means over the space of maybe 1 week or 1 month is when they collected the data. They didn't collect it continuously over a period of years. Okay? That's a cross-sectional study. Retrospective or case control study, the data are collected from history, basically, going back in time and examining records or interviews that have already taken place. So they're looking at historical data, data that was already collected. Prospective, retro means behind, pro means in front of. So prospective or longitudinal cohort study data are collected from groups sharing common factors called cohorts over a period of time. So they are collected over a period of time. in the future, not in the past, basically, over a period of time from now till whenever. Okay? Replication is the repetition of an experiment on more than one subject. Samples should be large enough so that the I've got to remember what this one is. Okay, so that the study that is the variable that's being studied, the variable that's characteristic of very small samples will not disguise the true effects of different treatments. For example, giving people that have high blood pressure a new high blood pressure medication when some of them are taking an aspirin every day and some of them aren't. The aspirin may be actually influencing whether or not the other drug works, is what they're getting at. Variable. I was reading the next one, sorry. Blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment, which is the real thing, or what's called a placebo, P-L-A-C-E-B-O, placebo. P-L-A, I'll write it up here. It's placebo. That's what it looks like. P-L-A-C-E and then B-O. Blinding allows us to determine whether the treatment effect is significantly different from the placebo effect, which is where, if you have a headache and somebody gives you a pill, and they tell you it's a headache pill, and your head feels better because you took a pill, and then later on they tell you, well, that was just a Skittle. Okay? You thought you were going to get better because you took some medicine. That's called a placebo effect. And that occurs when an untreated subject reports improvement in symptoms when they really didn't get any treatment. And at the bottom, I think I mentioned this, but I'll go back over it again. Blinding occurs at two levels. The subject doesn't know whether he or she is receiving the treatment or a placebo. And the other one is where the study administrator just call them the study admin. Or they sometimes will call that the experimenter, or there's lots of titles for it, but the person conducting the study is basically what you're looking for there. They don't know whether they're giving them the drug or not. Okay. Sampling lab. We're going to do a quick example of each one of these, and then I think I'll save the review of this for next time. So let's just go through how you do these. Let me scoot this up a little smaller because y'all have got a copy of it. You don't really need to see. Stop that. You don't really need to see mine so much. And I'm going to need to see a calculator to show you how to do this. Okay, before we start, who does not have a calculator? Like that kind of? You have to have a TI-83 or 84. Or the equivalent on your iPad that will do it, on your iPhone. You need to have one, period, but if you don't have one with you, go to your desktop on your computer and find an icon that looks like a little calculator. Mine's right here. Okay? It says calculator, blue. Before you, try double clicking on it and see if it will open. If it will open for everybody, then good. And if it doesn't, then I'll tell you what to do. So everybody try to click on it. You can actually make it bigger or smaller. Just grab the edge of it and drag it. Of course, now if you make it too big, you can't turn it off and on. Yeah. Everybody find one? Okay, I think you need to make that smaller. Grab it on the corner. Oh, good grief. I never saw one that big before. That'll work. I think we just exit without saying the state. Try that again. Don't drag too quick. I can't read. That should be good. Okay? It was. Okay, has everybody got your calculator handy? Okay, right click on it. Go to property. Click on compatibility. Look on with him. You might be able to download it anyway from the junk phone. You can on an iPhone. I don't know about all of them. Okay, let's get going on this so we'll get finished. Because we've only got, about 20 minutes left. So we're not going to get done, but I'm going to get you going on this. Okay, what it says is we're going to take first a convenience sample. This one's going to be quick. I'm not going to give you time to think too much about it. I want you to pick 8 of those kids. You're going to do a survey regarding kids and sports. That's why you're picking these kids. You're allowed onto the playground at the school to ask the students questions, but you only have your clipboard and a pencil to record the answers. That's it. Which 8 kids are you going to choose? And I'm not doing this part with you. And I'm only going to give you about 3 or 4 minutes to decide. Pick 8 kids to survey. There's no right or wrong. Pick 8 kids. But be prepared at some point to tell me why you picked each kid. No, I didn't say that. I said pick 8 kids that you think are representative of the kids in that school. Just pick 8 kids that you think would represent those kids in that school. You're going to ask the question about sports. Circle the 8 kids and then letter them A, B, C, D, E, F, G, H. No, I actually don't just yet, although for homework I do. Okay, there's the school kids. Now, I'm going to ask you to answer those questions after you get out of here about why you picked each kid. those answers will reveal something to you, I'm sure. But I'm just going to ask you a couple questions here. Raise your hand if you chose this kid right here. All right, everybody look around. Why'd you pick him? Okay. Just think about it. You don't have to answer. Okay. How many people chose this kid? Little Mr. Muscle Man. How many people chose that kid? No? Too hyper, okay. Now here's the trick question. How many people chose that kid? Okay. Now here's the thing. Those of you that chose that kid, why, and I am going to ask you to say, why did you pick that kid? Okay. So you're trying to be inclusive, right? Okay. What assumptions were you making about the others that I asked you about? Because they were wearing roller skates or jumping rope or making muscles, or maybe the little guy down there with the baseball glove in the very bottom corner. Very bottom corner, under the girl with the pink dress. Now this one right here, a lot of people picked that one. How many people picked her? The lady in the pink dress, right next to Mrs. Gregory. Okay, now what was your goal? Remember what your goal was. You're actually being a researcher, a statistician now. What should your goal have been trying to pick this sample? Right, the broadest spectrum of individuals possible, but a sample which was representative of the entire group. And by looking solely at characteristics of those students that you had that question in mind, oh, I'm going to ask them about sports, I probably want to ask this kid, but not this kid, because this kid looks like they might like sports. That's bias, folks. We're all guilty of it. Every single one of us, we're all guilty of bias. We can't be unbiased. We're human beings. We can try really hard not to be. But even when we don't intend to be, we are. Statistically, we are going to introduce bias by taking a convenient sample. That's why I want you to write your answers to those questions and bring it back when you turn the assignment in. Now, with those 8 kids circled, just to kind of hold them aside, and I'm going to show you how to take a random sample from those same kids. You're going to answer why you picked kid A, kid B, kid C, and so forth. And your answer is not right or wrong. It's just it's why did you? Okay? This is to learn something about why it's so hard to pick a good sample for homework. So we're on page 2 now. How many total kids are there in this school? I believe there's 34. Should be 34. It's been 34 every time I've done it. Okay? I want you to number these kids. I do not care how you number them. Just number them 1 to 34. I don't care if you go around and number these, and then number these, and then these, or if you just go across the top of the page back and forth. Don't care how you do it. Number them 1 to 34. Yeah, you're going to do it on the second page too, but wait till we get there. And you don't have to do it the same way on the second page either. Or the third page. Yeah, we're doing it on the second page. We're on the second page, but the next page is going to ask you to do it again. We're on page 2, sorry. We're on the one that says simple random sample. And I don't, like I said, I don't care how you number them. I don't care if you number them the same as I'm fixing to number them or not. There is no right, wrong, or otherwise way to do it. Just number them. Everybody gets a number. Now, I doubt anybody numbered theirs exactly the same way that I did. It really doesn't matter if you do or not. We are going to randomly choose 8 of those kids. And here's how we're going to do it. First thing I want you to do, with your calculator turned on, doesn't matter what's on the home screen, you can clear it off if you want to, whatever. I want you to hit the number keys that correspond to the last 4 numbers of your cell phone number. The last 4 numbers of your cell phone number or your best friend's cell phone number or anybody's cell phone number. Pick 4 numbers. Doesn't matter what the numbers are. Here again, there's no right or wrong to it. Pick 4 numbers. Just don't pick the same 4 I did. That's fine. Any 4 numbers will do. 5555. Doesn't matter. Pick 4 numbers. Press the stow button down here on the bottom next to the number 1 key. It puts an arrow on the screen. It's going to store whatever number you've typed in. Then I want you to press the math key. And I want you to press the right arrow key until you get to PRB. And I want you to hit enter 2 times. Math, right over to PRB. Choose RAND, R-A-N-D, first thing on that screen. Press enter 2 times. And all you're going to see is that. Now, what you did wasn't anything that is world-shaking. It isn't anything statistical. Every one of these comes out of the box, pre-programmed to start at the same number when it randomly generates numbers. And we don't want that, because that means that every time one of us uses it, we all get the same random numbers, and that's not very random. So we just reset the starting point, or what's called the seed base, for the calculator to randomly generate numbers. So everybody's going to get different numbers now. If you get it that big, I bet you're never going to get it that small again. That's what happened to Peter. His got stuck. Okay, now we're going to randomly, and you can write this down on your paper up here. You're going to you number the students 1 to 34. This is the calculator command that we're going to put in the calculator, and you're going to have to follow me to see how to do it. It's RANDINT parentheses 1, 34. Here's how we get it. And if you want to write down your keystrokes up here, you can. Math, over to PRB, down to number 5. What does number 5 say? It says RANDINT parenthesis, which is part of what you have that you need. So when you go Math, PRB, and choose number 5 and press enter, it copies that over onto the home screen. Now you type 1 and then a comma and then 34. Your comma's right above your number 7. And then close your parentheses. What you are telling the calculator to do is I want you to randomly select me a number between 1 and 34. Okay? And you just hit enter. Now everybody will, most of us are going to get different numbers because there's not 34 people in here. Somebody may get the same number. You may have gotten 21 like I did. So I'm going to pick student number 21. Okay? Let me see where you are, because that's... Oh, you got an 84, that's why you're just good. No, it's not. Lower is 1, upper is 34, and then... Okay? Now, if you'll press it again, press the enter button again, it will pick another student. Mine picked 28. Now, yours may pick someone else. It may pick the same one it picked last time because that's possible. If it picks the same number again, skip that one. You can't circle anybody twice. Circle the students that correspond to those numbers. And keep going until you've circled 8 students. If you get repeats, don't circle the student again. Just hit enter again and get another one. There's my 8 students. My 8 students probably are not the same 8 students that you picked. Okay, now that is a random sample of 8 kids. That sample is most likely to be representative of the population. And even if you were thinking about the sports question, okay, here's a kid that does sports. Here's a kid riding a bike. Here's a girl that probably doesn't do anything about sports, but then again, who knows? Here's a guy that plays baseball. This guy still didn't get picked, but sometimes he does. And sometimes he doesn't. Okay? You're looking at well, you know, what overall should be true. You should have about the same number of boys and girls if the school is about the same number of boys and girls, but it's not an absolute requirement. But you were not biased at all in how you selected these. You had no reason for picking any of them. The computer told you to pick it, so you picked it. Okay? That's a random sample. Every kid in that 34 kids had the same chance of being in the sample as every other kid. And every sample of 8 had the same option of being chosen as every other sample of 8. Now we're going to try to get through one more, and then I'm going to leave you on your own. Same thing again. We're going to take a systematic sample, number your kids. It doesn't matter if you number them the same way that you did last time or choose something else. Everybody just has to get a number. We're going to randomly select a student to start with. We're going to randomly choose one kid. So we're going to do RandInt, which is math, PRB, number 5, 1, comma, 34, close parentheses. Math over to PRB. Select number 5, which says RandInt. Okay? And then put in the 1, comma, 34, close your parentheses and hit enter, and draw an arrow over that kid's head. Mine happened to be number 1. Okay, now we have chosen that first student. So up at the top of the page, there are 34 students. Number the students 1 to 34. Randomly select a starting place. The command you use is RandInt 1, comma 34. The random student that I started with is number 1. If yours is number 8, put number 8. If yours is number 4, put your number 4. If it's 22, put 22. Whatever random number to start with you chose, and put an arrow over that one. Now randomly pick a number between 5 and 10. I got 9. You might have gotten 4, or I'm sorry, no, you couldn't have gotten 4. You might have gotten 5, 6, 7, 8, or 9. You've got one of those numbers. Whatever that number is, that's your increment. Because I got 9, I'm going to start at student number 1, and I'm going to go to every 9th student after that. 1, 2, 3, 4, 5, 6, 7, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mine are numbered a little squirrely. And then from there, I'm going to count 9 more students. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, no, not that one. Next one will be student number 18. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So right now I have 1, 2, 3, 4 students, and I need to keep going. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have 1, 2, 3, 4, 5, 6, 7. I still need one more. 1, 2, 3, 4. 2, 3, 4, 5, 6, 9. So that you're counting every high permitting student. Every student after you want me to start with. And then numerical. We'll finish up next time. You can't start back over if you don't have enough. If you get 34 and you've only got 7, then you can go back and move on and keep on going. Yeah. Okay. Then you want to start at 29 and go 1, 2, 3, 4, 5, 6.
I feel like it'd be easier to roll dice. Stay over 6 minutes. I'm a rebel. I feel like I'm deceiving myself. How good I think I am.
It'll get better, it's just confusing at the beginning.